We all use high technology in today's generation. Over the past years, our population increased the demand of technology. These are some information that can help us learn further about why technology uses electricity and magnetism to start. What is electromagnetism? It is a fundamental process of nature used to describe how a magnetic field is created by the flowing of electric current.
Microphone. The most common use is the moving coil dynamic microphone, which is taken apart in this video. Did you know that speakers are basically reverse microphones? By applying a current to the magnet, it can move the diaphragm to produce the sound. Of course, the design of the device has to suit the production of a microphone can work thanks to electromagnetism. By creating a magnetic field and moving the coil through it, a signal is created that can then be used.
How do microphones work?
Though they have their differences in different uses, but they are all transducers, converting sound waves to an electrical signal. Dynamic microphone is the most common use. These work using electromagnetic induction. Sound waves hit a thin diaphragm which causes it to move. This diaphragm is attached into a coil, surrounded by a magnet. This magnet creates a magnetic field around the coil. The sound waves hitting the diaphragm are moving the coil, and the coil movements past the magnets creates an electrical current. This electrical current is your sound signal. Loudspeakers are basically reversed microphone.
Speakers come in all shapes and sizes, enabling you to listen to music on your iPad, enjoy a film at the cinema, or hear a friend's voice over the phone. In order to translate an electrical signal into an audible sound, speakers contain an electromagnet, a metal coil which creates a magnetic field and an electric current flows through it. This coil behaves much like a normal permanent magnet, with one particularly handy property, reversing the direction of the current in the coil keeps the pole of the magnet. Inside the speaker, an electromagnet is placed in front of a permanent magnet. The permanent magnet is fixed firmly into position, whereas the electromagnet is mobile. As pulses of electricity pass through the coil of the electromagnet, the direction of its magnetic field is rapidly changed. This means that it is attracted and repelled from the permanent magnet, vibrating back and forth. The electromagnet is attached to a cone made of a flexible material such as paper or plastic, which amplifies this vibration.
The hair dryer is an electromagnetic machine, which means that it uses electricity as its power source. Turning a hair dryer causes electricity to power on the motor that spins a fan located inside the hair dryer. The fan is what brings the room temperature air inside the hair dryer. The physical components of the hair dryer that help to get rid of water from your hair are the electric fan and the heating component, both of which are located inside the hair dryer. Room temperature air comes into the hair dryer through the vents. The air then passes a nichrome wire, which is used as a heating element. Nichrome is an alloy that is combined with both nickel and chromium. The nichrome wire acts as a resistor of the electric energy, which in turn creates the heat that the room temperature air passes through to become hot enough to get the moisture out of your hair. The hot air is then blown out the end of the barrel and onto your hair. How does the hair dryer create so much power? On most basic hair dryers, there is multiple options for the strength of air such as low, medium, and high. The way these different power options are created is with the blade's centrifugal motion.
Electromagnetic lock. An electromagnetic lock is a locking device that consists of an electromagnet and an armature plate. Locking devices can be either fail-safe or fail-secure. A fail-secure locking device remains locked strong enough to keep the door